Hello, in this part of the online tutorial of Explain-Esh, I come to the sections specific to parallel execution. So as you can see here, from serial execution, this section here, information on parallel degree based on Esh, simply tells you that Explain-Esh could not find any parallel execution activity in active session history, and therefore it simply skips this section and also the section that follows after if there is parallel execution detected. So if we switch to an parallel execution analysis, then we see here this section now has some content, and the idea of this section is that you see for each so-called DFO tree of the parallel execution plan a separate line. So this parallel execution plan here consists of two of these DFO trees. So you end up with two rows here that give you detailed information about this DFO tree. The idea is here that you get information about when was this DFO tree for the first time active. This is this start active information in seconds. So this means that this DFO tree on second number 2 after the execution started was found the first time in the active session history. So a sample that could be related to this DFO tree was found in the active session history. Whereas the second DFO tree here was found the first time only after 66 seconds. So for the first 65 seconds there was no activity found in active session history for this DFO tree. Then you get an information about how long was this DFO tree active, which means from this first time it was found, what was the last sample that could be related to this DFO tree. So the last sample for this first DFO tree in this case was found after 1 minute and 4 seconds, after 64 seconds. And again, likewise to the previous examples, you also get an information within this 64 seconds how many seconds was this DFO tree actually active. So it there might have been periods, seconds, samples, active session history samples where nothing was found related to this DFO tree. So in that case, this here would be less. In this case it's very similar, 63 seconds it was found active within the 64 seconds, so only basically 1 second where no sample was found. But it could look differently where you then see maybe far less activity within this total duration. Then you get an information about the total samples that could be found for this DFO tree, and you see the process count and the process unique count. And the idea of this process count and process unique count is that the process count is basically the unique number of different process names that were found. So for this DFO tree, 6 different parallel slaves could be identified in the active session history based on their name, which is then something like this P000, P001, and so on. And the process unique count in principle means the number of process names along with their serial number. So the difference between these two here, if there is any difference, indicates that the same parallel slaves were reused by being reallocated and deallocated. So they were reinitialized, which means that this DFO tree was then started several times. So if you have corresponding execution plan shapes, it's possible that a DFO tree is not only started once but started multiple times, and each time the DFO tree starts, typically the corresponding parallel slaves get allocated, and when it ends the DFO tree, then these parallel slaves get de-allocated. And each time a parallel slave gets allocated, the same logical parallel slave name might get reused, like this P000 stays the same, but the serial number will change each time it is reallocated. And therefore this process unique count, if this is greater than this process count, it means that although the name stayed the same, the parallel slaves got reinitialized. And the difference between these two numbers should simply give you an idea how often these reinitialization might have happened. And since this is an overhead and simply means that the execution spends time in this allocation and deallocation of the parallel slaves, that's the reason why I added this, so that you get an idea by looking at these figures that there might have been a significant overhead if there is a huge number of process unique count versus the process count. In this case here, there is no difference, so obviously these parallel slaves, at least according to these active session history entries, were not reinitialized, so they were only allocated once. And to give you just an idea how this could also look like, I have here a different example where we can already see here in this real-time simple monitoring, which is about the same information, if you want to say so. So we have here, this is a quite complex example, so we have even different degrees in this execution plan, so different DFO trees that got different parallel degrees. And we also have here these significance that although we have a degree of 8 or 2, many hundreds of parallel slaves were requested and allocated. So this is obviously an example where DFO trees got started multiple times, otherwise you wouldn't come to these figures, that you only have that low degree but that high number of parallel slaves that were allocated. And if I go now to this section with this parallel degree information, we see here that Explain-Ash found 4 DFO trees. This is from an older version, therefore it's still called DFO here, but in the most recent versions this is called DFO tree. And you can see here for this DFO tree number 1, you can see here this difference that the process count is 3, but the process unique count is 29. So across these 42 samples, so you have to put this count here always in relation to the sample count. It's not a measured count because it's based on this active session history sampling. So if I put this into relation, then for many of these different, for most of these, for 3/4 of these samples, of these 42 samples, for 29 of them, different process unique counts were found. So different serial numbers were found for the same process name. So they got reused, they were reallocated, and these DFO trees, when these DFO tree number 1 was obviously then started several times. So that's the idea of this process count versus process unique count. It's in particular relevant if you look at an Explain-Ash report that doesn't have the corresponding real-time SQL monitoring information available. So if this section here is missing because the real-time SQL monitoring report information is no longer available, then this here gives you an idea about this information that you also see from these figures here. Since in case they are missing, then this information here should give you a similar idea that these processes were reused, these parallel slaves were reinitialized if this number here is greater than this number. So the next information that we see here about this DFO tree is Explain-Ash tries to understand how many parallel slave sets this DFO tree allocates, and this can be either 1 or 2. So very simple plan shapes for this DFO tree might just require a single parallel slave set, but for the most parallel execution plans you will end up with 2 slave sets. That is the set count, so it's either 1 or 2. And then we come to this assumed degree, which is might be different from this actual degree here. The point is simply here that for versions lower than 11.2, there is no actual degree that can be determined from the active session history, because this px flags column was only introduced in 11.2. So for such versions you will only find this assumed degree column here, and this is an attempt by Explain-Ash to find out the maximum number of parallel slaves that were identified in the active session history samples per slave set. So in this case here, this corresponds to the actual degree, and it's basically a best guess that Explain-Ash can do based on the active session history samples. If you, for example, have an execution where only a few samples were actually only recorded in active session history, or if you have extreme skew, so that only a few parallel slaves are actually active out of a larger parallel slave set, then this assumed degree can be wrong and can be too low, simply because Explain-Ash only found these couple of parallel slaves in the active session history samples. But usually if there are a sufficient number of samples and there is not too extreme skew, then this assumed degree is usually quite a good guess, but it's just something that you have to keep in mind, that the assumed degree might be wrong. Whereas the actual degree is then based on this px flags column and should give you the actual degree used at runtime, which of course could be different from the expected degree. Active session history unfortunately doesn't contain any information about why you might not have reached the desired degree. So if you had a so-called downgrade for whatever reason, less parallel slaves were allocated, then this is not something you can tell from this here. It just tells you the actual degree used. Then we come to this average active sessions information, which gives you an indicator about the work distribution, how well was the data distributed. So if the idea is that this average active sessions should be close to the degree used, so due to this fact that you have often these 2 sets of parallel slaves, the average could even be higher than the actual degree. So if both sets were slaves, or of both sets were active significantly, then the average active sessions could actually be higher than the degree. But the idea is that this gives you more granular information about the average active sessions than this global information. I've already talked about this average active sessions here in this part. For the global overall summary, you will also get this average active sessions, but for the parallel information on DFO tree level, you also get this, because it's simply possible that some DFO trees might be affected by work distribution problems, whereas other DFO trees of the same execution plan might not be affected by parallel execution skew, so by work distribution problems. And here you get a more granular breakdown, so the average active sessions on DFO tree level. In this case here, both DFO trees have seem to have not too big issues with the work distribution, but as we will see later on, this is not always that significant here, so it might be misleading. In order to find out if you really have a good work distribution, you will see more information that you should check. So quite often this average active sessions is a good indicator, should give you a good idea whether you have a problem with work distribution or not. But as we will see in this case here, there are also cases where it's not such a good indicator. Likewise, we see here this middle value, this median average active sessions, and then the maximum. In the most recent versions you also find here, just to give you an idea what is the minimum and maximum average active sessions found. So in this case here, there was at least one sample point where actually 5 out of these 6 allocated parallel slaves were active. So in this case then obviously both sets, slaves out of both sets were active. Minimum average active sessions and this standard deviation you probably can ignore, as I already outlined in the previous parts of the tutorial. Then one thing that I personally find quite revealing is that I also try to give you an idea about when was this DFO tree actually active. So in this case here we can see that this DFO tree number 1 was active right from the start. As I already said, after this second here it was found to be active, and it stayed then also active for most of the time, which was also already indicated by these figures here, 64 seconds active, and out of these 63 seconds it was found to be active. So it was, for the overall execution, this DFO tree was active for most of the time. And then the second DFO tree, this DFO tree number 2, which only consists of one slave set at the same degree of 3, this was only active then for 7 seconds, and within the 7 seconds it was found to be active at every sample. So we see here this graphical representation. So DFO tree number 1 was active from the start, and then the second DFO tree got active until the end of the execution. So this is a typical example where one DFO tree is active after the other, which is a typical pattern that you see with this temp table transformation. So if you have a parallel temp table transformation, or maybe multiple steps of these temp table transformations, then you would see one DFO tree active for some time, then the next DFO tree starting afterwards, and then maybe the next DFO tree and the next DFO tree, until the main DFO tree starts the final DFO tree, which then produces some result or perform some DML, whatever. So this is the graphical representation. And the other example that I showed you, where one of the DFO trees was started multiple times, we would then actually see a different graphical pattern. So in this case we can see that this DFO tree number 2 was active from more or less the beginning of the execution, was then active for a couple of seconds, in this case just 8 seconds, and then this DFO tree number 1 became active, which could be such a temp table transformation. Not really, because temp table transformation typically starts with the first DFO tree, and then the second, third, and so on is active, so that we see here the second DFO tree being active before the first DFO tree is a pattern that you shouldn't see with the temp table transformation, parallel temp table transformation. But the point that I'm trying to make here is that you can see that this DFO tree number 3 here was actually active at the same time as the DFO tree number 1. So this is one of the examples where multiple DFO trees are active at the same time, which is possible depending on the plan shape. And this also means that this is an example where the parallel slaves of this DFO tree here will be active at the same time as the parallel slaves of this DFO tree, which is, by the way, also an example where we see different degrees for the different DFO trees. So the point here is that this graphical representation should give you a very easy approach, understanding whether this is a parallel execution plan if you have multiple DFO trees, if this is an execution plan where one DFO tree is active after the other, or whether you have an execution plan where multiple of these DFO trees were active at the same time, which is then gives you some ideas about maybe why this parallel execution could have more parallel slaves allocated, more used than you might have expected in first place. Because, as I said, here you now have this situation where these different parallel slave sets of these different DFO trees are allocated at the same time. So you have more parallel slaves allocated than you usually expect. Yeah, and that's the reason why I added this graph. So this should give you an idea what kind of execution plan shape you look at here. Usually you can expect that if you have a plan shape where multiple DFO trees are active at the same time, it is not an efficient use of parallel execution. So you probably do not really reach that reduction in overall runtime that you might expect from parallel execution, simply because this is as I already said, this is related then to lots of overhead with allocating, deallocating parallel slaves and so on. So this is usually something where you should be warned and check carefully whether this execution plan shape, this overall execution plan, makes sense, is reasonable and really efficient. In most cases, something like that, it's not really a good use of parallel execution. Yeah, so that is what you get from this information on parallel degree. So on DFO tree level, the information about some details that should give you a better idea of what is happening. And then just have a look, let's just have a look at an example that executed on rack. So we have a cross instance parallel execution here. Then this section looks like this. So you have this global level, which corresponds to what you see for the single instance case. Here you also have this example where the average is actually higher than the actual degree. Apart from that, it's very similar. You get the same information, but you get in addition also a breakdown on instance level. So for each DFO tree, you get for each instance that was involved and found in active session history, you get here again a more granular breakdown. So you could, for example, have the case like here where I have basically deliberately caused this by requesting a degree of 3 but having 2 instances involved, which means that somehow the allocation of parallel slave across these instances has to be unequal. So 4 slaves were allocated from this instance and only 2 slaves for this DFO tree were allocated on this instance. Likewise here we have just 1 slave allocated here and 2 slaves allocated from this instance. So this is a kind of information that might be useful to give you an idea to what degree these instances were involved. Maybe if you have different load patterns on the instances, then parallel execution might deliberately allocate more slaves from one instance than the other. So these scenarios, all this information, you can then tell from this information here on instance level. Likewise, you might have a situation where one instance was simply more active than the other instance, was more involved in the overall execution. Again, you could be able to tell this from this time active graph, respectively from this duration active. We can see here that although both instances were actively involved for 50 seconds overall, this instance here, number 1, was active all of the time, whereas this instance was only active for 33 seconds within this 51 total seconds of activity. So this instance number 2 obviously had less to do than the other instance, not only in terms of less parallel slaves, but also in terms of these two slaves were not found to be active at each sample, but only at 33 seconds. Yeah, so that's what you get in addition for a cross instance parallel execution, and apart from that, it's the same information. You can see here that I do not repeat this information here because the degree and set count is of course something that is valid across the whole DFO tree, no matter how many instances are involved. So just to explain why this is left blank here, this is only reasonable to specify on global DFO tree level, whereas the remaining information then is for each instance that was found.